Chapter number 7, alternating current. Now, in a previous chapter, we discussed about AC generator. AC generator produces alternatively changing voltage, means when this AC supply voltage is given to any circuit, then the current constituted, that is called AC current or alternatively changing current. Okay, we know this thing in our house or in our industries. The main supply, that is AC supply voltage, and this AC supply voltage is used widely because it is convenient to increase or decrease the voltage with the help of transformer in case of AC voltage, as well as it is easy to transmit from one place to another place, and it is also economical to transmit from one place to another place to this AC supply or AC voltage. So now in this entire chapter we will concentrate our mind on AC current. Okay, now see, first theory, when AC voltage is applied to a resistor, then what will be the current in the circuit? What will be the power consumed? That we have to discuss in this particular theory. Now see, AC supply voltage, that is represented by the symbol of circle with the sign of wave. Okay. Now this AC supply voltage is connected with resistance R. Suppose at a particular instant, the current in the circuit, that is I. Okay. Now here be careful, whenever for any AC circuit you represent the current in the circuit, then always represent time with it, because this one is alternatively changing current, means the direction of the current is continuously changing as per the positive, negative half cycle of AC supply voltage appears here. Okay. So this is the current at a particular instant t. So that we have to represent. Now AC supply voltage V, that is Vm sin omega t. Okay. Now as per Kirchhoff's second rule, we can write here, if current I is flowing through resistance R, then V equal to IR, and V, that is Vm sin omega t. So we can write I, that is Vm by R into sin omega t. Now Vm by R, that is maximum current in the circuit when the value of sin, that is 1. So we can write the equation now, I equal to Im sin omega t, where Im, that is Vm by R. And this is the equation for instantaneous current. Now here we can observe this thing. The voltage equation, that is Vm sin omega t, current equation is Im sin omega t. It implies that the phase difference between voltage and current, see, at a particular instant the phase of both one, that is omega t. So phase difference between these two means phase difference between voltage and current, that is equal to 0. Okay. Now average current in the circuit, that will be also equal to 0, because now in the circuit your current is continuously changing from plus Im to minus Im, depending on the values of sin omega t. Okay. Now here average current in the circuit is 0, it doesn't mean that the power dissipated here, that is 0. Current is 0. Power, that is I square R. So power depends on the square of the current. So it will not be 0. Now see, instantaneous power, that is voltage into current, that we can write V equal to IR, so I square R. So power P, that is I, that is Im sine omega t. So we can write Im square R sine square omega t. Now this is the instantaneous power at a particular instant t. Average power over one cycle, that is average of this Im square R, that is constant. So we have to take average of sine square omega t. So average power, that is Im square R into sine square omega t, that is 1 minus cos 2 omega t by 2. So we can write average power, that is Im square R by 2 into 1 minus cos 2 omega t. So Im square by 2 into R, 1 is constant. So we have to take average of cos 2 omega t. But average of cos 2 omega t over one period, that is equal to 0. So simply we can write average power, that is Im square by 2 into R. Now here, to represent power in the form of equation which we use for DC power, simply voltage into current, right? So here the effective current in the circuit is defined as RMS current. RMS current means root mean square current. Now root mean square current means, first of all, we have to take square of the current, then we have to take mean of it, and then after we have to take root of it. So let's see what will be the RMS current. See, we have the instantaneous current, that is I equal to Im sine omega t. Take square of it. So I square equal to Im square sine square omega t. Then after take average of it and then take square root of it. So I RMS, that is capital I, that is the effective current, that is under root average of I square. So capital I, that is now I, that is Im sine omega t. So Im square and average of sine square omega t, because Im square is constant and whole raised to 1 by 2. Again we can write Im square average of 1 minus cos 2 omega t by 2, because sine square omega t is 1 minus cos 2 omega t by 2. Again we can write here Im square by 2 and average of cos 2 omega t, that is 0. So simply we can write IRMS or effective current capital I, that is Im by root 2. Okay. Now directly we can write the RMS voltage also, Vm by root 2. If we solve in the same manner, V equal to Vm sine omega t, and we calculate VRMS, we will get the same value. Now see here, this Im square by 2. So Im square by 2, that is I square by 2, we can write, sorry, Im by root 2, that is your current I. So this one is our I square. So now we can represent power as capital I square into R, or simply V into I. So this one is, so when AC voltage is applied to resistor, what will be the instantaneous current in the circuit? What will be the average current in the circuit? What is the instantaneous power in the circuit? What is the average power in the circuit? And what is effective current itself is the RMS current in the circuit. All these things we discussed. Clear to all of you? Any doubt in this one? Now see, representation of AC current and voltage with the help of rotating vector. And this rotating vector, that is called phasor. That is called phasor. Okay. Now see, suppose we prepare the graph of voltage or current versus omega t. Then this red graph itself is the sine curve, because our voltage is Vm sine omega t. Our current is Im sine omega t. So this black one, that is the current, and this red one, that is voltage versus omega t graph. Clear? Okay. Now, how we represent voltage and current with the help of rotating vector? Say, at any time t, suppose we consider here instant t1. So at any instant t1, if you want to represent the voltage and current with the help of vector, then how to represent it? Here we have to prepare the vector having magnitude equal to maximum value of the voltage, and that should be in the direction making an angle equal to phase of it with respect to x-axis. So at any instant t1, here we substitute t equal to t1, then phase will be omega t1. It implies that now we have to represent the vector at an angle omega t1 with respect to x-axis. So now in this direction we have to represent the vector, but the magnitude of this vector, that should be equal to maximum value of voltage, and to represent current for the vector which one is representing current, again the maximum value, that is Im. So we have to take magnitude of that vector, that is Im. So see here, one vector, this red one, is representing voltage. This black one is representing current. Now at any instant t1, the phase, that is omega t1. Now at time t1, if we want voltage and current, very simple, take the projection of these phasors representing voltage and current on y-axis. So if we take the projection of this phasor of the current on y-axis, then it will give you Im sine omega t1. And here if we take the projection of voltage phasor on y-axis, we will get Vm sine omega t1. Now see, as time changes, this angle will change. If this angle is changing, then your vector, that will be now like this, it will be rotating vector. So this particular rotating vector itself is called phasor. Now if our voltage or current is changing as per sine omega t, then we have to take projections on y-axis. If we consider it is changing as per cosine function, then we have to take the projections on x-axis. At any instant, you will get the voltage and current with the help of this phasor diagram. And now see here the phase difference. So at time t equal to 0, the voltage is 0, current is 0. Phase of both one at any instant t, that is same one. So we can understand this thing here. The phase difference between voltage and current, that is equal to 0. Clear? Example 7.1. A light bulb is rated at 100 watt for 220 volt supply. Find A, the resistance of the bulb, B, the peak voltage of the source, and C, the RMS current through the bulb. Very simple. The rating of the bulb that is given to you 100 watt. It implies that your bulb is consuming 100 joule electrical energy per second when it is operated at 220 volt. This is the meaning of rating. Now, power P, that is V square by R, we want to calculate resistance of the bulb. So make R as a subject. So we will get R equal to V square by P. V, that is 220. So 220 into 220 upon 100, you will get the resistance. Then after RMS voltage. So RMS voltage, capital V, that is Vm by root 2. Now Vm, the maximum value of the voltage, that is root 2 into V. Now here always remember one thing. Whenever in general the voltage is given to you or the current is given to you, just like here the voltage rating, that is this much. Okay. Sometimes they give you the supply voltage is this much. So in this manner, whenever the voltage or current is given to you, always it is RMS. Always it is RMS or effective. Whenever the maximum voltage or maximum current or the peak value is given to you, they will mention it. This is the maximum value or peak value, or sometimes they use the word amplitude. That is the Vm. Now here to calculate Vm, we can write Vm equal to root 2 into V. So root 2 into 220. Then C, the RMS current. So V, P equal to Vi. So I, that is P by V, 100 by 220, and solve it, you will get the current. Now see, AC voltage applied to an inductor. Prepare the circuit as shown in the figure. AC voltage is connected to the inductor. At a particular instant, the current in the circuit, that is I at time t. Now, suppose the supply voltage, that is V equal to Vm sine omega t. Now, if current I is flowing through inductor having self-inductance L, and this current is changing, then the back EMF, that is L di by dt, in previous chapter we studied this thing. So if we apply Kirchhoff's second rule to this particular loop, then we can write V minus L di by dt, that is equal to 0. Therefore, L di by dt, that is V, and that is Vm sine omega t. So we can write di, that is Vm by L sine omega t dt. This dt is taken on this side. Now if we integrate this equation, then integration of di, that is I Vm by L as it is, then integration of sine omega t, that is minus cos omega t upon omega. So we can write I, that is equal to Vm upon omega L into minus cos omega t. But now write down the equation of current in terms of sine function. So we know this thing, minus cos omega t, that we can replace by sine omega t minus pi by 2. So here I that we can write as Im sine omega t minus pi by 2. Now see here, Im that is Vm by omega L. Here Vm by omega L that is replaced by Im that is the maximum current. This is maximum voltage. Voltage divided by omega L means voltage divided by something that is equal to current. It implies that this is something that should be the resistance. So this omega L that is denoted by XL, and that is called inductive reactance. And inductive reactance is nothing but the resistance offered to the circuit by inductor when it is connected with AC supply. Now, here see these two equations of voltage and current. So at any time t, the phase of voltage is omega t, but at the same instant t, the phase of current that is omega t minus pi by 2. It implies that when AC voltage is applied to inductor, the current lag behind to voltage in phase equal to pi by 2. Clear? Now, instantaneous power supplied to inductor. Power P that is V into I. So Vm sine omega t into I that is Im minus cos omega t. So minus Im cos omega t. I equation મૂક્યું છે અહીંયા, huh? So now minus Vm Im. Now multiply this equation by 2 and divide by 2. So here we can write 2 sine omega t cos omega t by 2. Therefore, resultantly power P that is minus Vm Im by 2 sine 2 omega t. This is the instantaneous power at any time t. Now average power over one complete cycle. So minus Vm Im by 2 that is constant one. But now when we take the average of the sine 2 omega t, that will be equal to 0. So in case of inductor connected to AC supply, the average power over one cycle that will be equal to 0. Clear to all of you? So now let's prepare the voltage current versus omega t graphs and the phasor diagrams. See, voltage is Vm sine omega t, means voltage graph that will be the sine curve. But now for current, at time t equal to 0, Im sine minus pi by 2 sine minus pi by 2 that is minus 1. So I equal to minus Im. So your current will be this much at time t equal to 0. Now if you take omega t that is pi by 2, then pi by 2 minus pi by 2 sine 0 0. So your current is 0. And then after it follow this sine function like this. Clear to all of you? Now phasors. So voltage phasor at any time t, the phase is omega t. So we have to represent the vector having magnitude equal to Vm in the direction making an angle omega t with respect to x-axis. So that is the phasor of voltage. Now, if we take the projection of this one on y-axis, then we will get Vm sine omega t. That is our voltage at any instant. Now, current lag behind by voltage by pi by 2. એટલે કરંટ એ વોલ્ટેજ કરતા પાઈ બાય 2 જેટલો પાછળ ચાલે છે. તો હવે આપણે અહીંયા કરંટ નો ફેઝર વોલ્ટેજ ફેઝર થી પાઈ બાય 2 એંગલે લેગ બિહાઇન્ડ રિપ્રેઝન્ટ કરવો પડે. તો હવે આપણે અહીંયા એક વેક્ટર લીધો, which one is with length equal to Im, means magnitude is Im, and now this vector is represented at an angle pi by 2 with respect to voltage phasor, but here minus pi by 2 means lag behind. So here in fourth quadrant it is represented. Clear? Now angle made by Im with x-axis, that is omega t minus pi by 2. So this part. Now if you take the projection of this one on y-axis, you will get Im sin omega t minus pi by 2. So that is your current at any instant t. So now with the help of this phasor, you will get voltage and current at any instant. Clear to all of you? Any doubt in this one? Now current is Im sin omega t. So your voltage, that is Vm sin omega t plus pi by 2, means here we used the concept, that is this one. When inductor is connected with AC supply, the current lag behind by voltage in phase equal to pi by 2. So the same thing that you can represent like this. When the inductor is connected with AC supply, the voltage lead the current in phase by pi by 2. એટલે current voltage કરતા pi by 2 પાછળ છે એવું કહીએ, અથવા તો voltage current કરતા pi by 2 આગળ છે, સેમ વસ્તુ થઈ. એટલે એ કોન્સેપ્ટ થી આ બે ઇક્વેશન લખ્યા. તો હવે see this red curve, that is the curve of current I versus omega t. This black one, that is of voltage versus omega t. Now see here, 0 to pi by 2. During this one, voltage and current both are positive, so power P, that is V into I, positive. Right? So here, then after at pi by 2, voltage and current. See, voltage is 0, current is maximum, so V into I 0, power becomes 0. Then after current, voltage. Current is positive, voltage is negative, therefore power, that is negative. Then again at pi, it is 0. So this blue curve, that is the graph of power versus omega t. Now see here what happens. When we take value of omega t, that is pi by 2, then omega, that is 2 pi by t. So small t, that you will get capital T by 4. See, omega t 2 pi radian means one cycle is completed, that is periodic time, capital T. So when 1/4 cycle is completed, means during time interval 0 to T by 4, inductor will absorb the energy from the source. Absorb the energy from the source. Clear? And then after, see the second cycle. During T by 4 to T by 4, means T by 2 time interval. the energy stored in the inductor that will be transferred back to the source. Again, 2t by 4 to 3t by 4. The energy is absorbed by the inductor from the source. And then after 3t by 4 to capital T time, the energy stored in the inductor that will be transferred back to the source. Clear? So in this way, during this entire cycle, 0 to capital T time, the the magnetization of inductor and demagnetization of inductor that continue. And due to this particular reason, the average power that comes to 0. So we can use inductor in the circuit to control the current without loss of power. Okay. So if you want to minimize the power loss and you want to control the AC voltage applied to a capacitor. Now AC supply voltage is connected with the capacitor as shown in the figure. AC supply voltage, that is Vm sin omega t. Now suppose when we switch on the circuit, then after at some instant t, charge on the capacitor is Q. So potential difference across two plates of the capacitor, that is Q by C. So we can write V equal to Q by C, and that will be equal to Vm sin omega t. So Q, that is Vm into C sin omega t. We want instantaneous current. So differentiate this equation of charge Q with respect to time t. So I, that is dq by dt. Now d by dt of Vm into C sin omega t. So Vm C as it is, differentiation of sin omega t, that is cos omega t, and of omega t, that is omega. So resultantly our equation of current, that is Vm omega C cos omega t. This Vm into omega C, that is maximum current, because when cosine is 1, you will get this maximum value of the current. So I equal to Im. Now this cos omega t, that you can rewrite as sin omega t plus pi by 2. In trigonometry you study this thing. So why we write in this manner? Because now here you can see your voltage is Vm sin omega t, your current is Im sin omega t plus pi by 2. Means at any time t, see, at any time t, the phase of voltage is omega t, but the phase of current is omega t plus pi by 2. So here we can observe this thing. In case of capacitor connected with AC voltage, the current lead the voltage by pi by 2, or in other words we can say voltage lag behind in phase equal to pi by 2 with respect to current. Okay. Now Im, that is Vm into omega C. So rewrite this equation like voltage upon something. So we can take this omega C as denominator to denominator. So we can write Vm upon 1 upon omega C. But voltage upon something, which one is giving you current? So definitely that something is the resistance. So here this 1 upon omega C, that is represented as Xc, and this Xc equal to 1 upon omega C, that is called capacitive reactance. Means that is the resistance offered to the circuit by capacitor. Now instantaneous power supplied to capacitor, power P, that is V into I. So Vm sin omega t, Im cos omega t. then Vm Im sine omega t cos omega t multiply and divide by 2. So we can write Vm Im by 2 into 2 sine omega t cos omega t. So instantaneous power, that is Vm Im by 2 into sine 2 omega t. Now, this is instantaneous power. But if we think about the average power supplied over one period or one complete cycle. So we have to take average of sine 2 omega t. But average of sine 2 omega t, that is equal to 0. Now, phasor. So voltage phasor at any instant t, it is in the direction making an angle omega t with respect to x-axis. Okay. Now the magnitude of this vector, that is Vm. Now current lead the voltage by pi by 2. So current phasor is represented in the direction making an angle plus pi by 2 with respect to Vm. So the total angle of this current phasor with respect to x-axis, that is omega t plus pi by 2. So these are the phasors. Now here see, suppose we think about the graphs of voltage, current, power versus omega t. Then see V equal to Vm sine omega t. So this red curve, that is the graph of voltage. Then Im sine omega t plus pi by 2 means Im cos omega t. So this is cosine curve for current, and this is power. So current, voltage both are positive, power is positive. This. Then one positive, another negative, power negative. Again, both negative, voltage, current, both negative, power is positive. One positive, one negative, power is negative. So again here see what happens. In time interval t equal to 0 to t equal to capital T by 4 means during 1/4 part of the complete cycle, capacitor charged means capacitor absorb the energy from the source and it store the energy in the form of electric field. Then during second 1/4 cycle, capacitor will discharge and it will supply the energy to the source. Then after, the voltage cycle is changed from positive to negative. So again during that, the charging of capacitor will take place, but now the polarity of plates will be changed. So during the third 1/4 cycle, again the charging process of the capacitor will take place and capacitor will store the energy in the form of electric field. And then during fourth 1/4 cycle, the capacitor will discharge and it will supply the energy to source. And during this entire cycle, now we can say the average power, that is equal to 0. Clear to all of you?